today we're gonna start part 1 of networking. It's gonna be networking in general. It's not gonna be networking in Linux. So we're gonna talk about a lot of concepts we're gonna see now. So welcome to day 7. Let it load the screen. Okay, so welcome to day 7. So this is basically a picture that describes networking. So today we're gonna talk about introduction to networking, into the network concepts and components, protocols and ports. Also, we're gonna talk about IP addresses and subnets and CIDR blocks. Then we're gonna have a break. Then we're gonna continue by introduction to Linux networking and firewall configuration, best practices, some troubleshooting, and we're gonna do a little bit of in-mapping, a little bit of Wireshark, a lot of stuff that cybersecurity students use. So we're gonna do that today. So, are you guys ready? Do you have any kind of information about networking before we start? Like, do you know about classes, classless, the types of IPs, protocols, and ports? Does anyone have any kind of idea or basic knowledge? Yes. Yes, it's your favorite subject, Sabine. Hopefully. We are ready. Let's go. Okay, great. I love the enthusiasm, Omar. I'm loving it. I have basic knowledge. Yeah, it's gonna be a little bit about basic knowledge. We're gonna also take a look in the cloud. So, we're gonna see the basic introduction about what is networking. So, networking is the practice of connecting computers and other devices to share resources, which is like basically clear to us. So, networking is just combining multiple devices or multiple computers together to maybe exchange data or share some resources or make communication or facilitate communication. So I think the concept of networking is basically relatively easy also to understand. As the picture here says, let's go to the introduction of Welcome to Day 7. We're going to see that all computers are connected using this frog right here. It's called, I think it has a meme name. I forgot his name, but that's fine. Okay. So we're gonna talk a little bit more about network concepts and components. We're gonna see network concepts, number 1, which is types. So these concepts, um, they're not just 3, they're more than 3. So we're gonna talk a little bit more about them. So the first one is LAN, which is LAN and WAN are like one of the most popular concepts of networks, but there's more than just these 3. So a local area network is basically when you communicate between 2 or more than 2 resources using not using the internet. So you connect them using maybe a switch or a hub, and this is used by called a LAN. So when you switch into using routers and you interfere the internet with it, it's gonna go from a LAN to WAN. So when you connect 2 LANs together using the internet, it's now called a wide area network, which is WAN. Also, we can understand a PAN, a personal area network. It's like right now I'm having my AirPods on, as you can see, and it's connected to my computer device. So it's a personal thing. So my headphones, my computer, a personal area network. This is also one of the types of networks. We have also, I think, multiple. We have the GAN, which is the global area network. I have not incorporated in the slides because it really doesn't matter to know these concepts for me. Like in the cloud, I never used them, to be honest. The GAN is like connected through fiber optic cables from or under the water, under the oceans. We also have CAN, which is campus area network. It's to connect 2 campuses together, maybe a college campus, like my college have one in Amman, which is the capital of Jordan, and one in Irbid, which is uh, another place in Jordan. So yeah, and we also have MAN, which is Metropolitan Area Network. So there is also multiple types of networks other than these slides, but I really don't need to focus on this topic right now. Okay, so another components are hardware of networks. So we said if we're connecting through switches and hubs, where the network is going to be called LAN or even network interface cards. See NICs here. So you need, no, I think NICs makes your computer connect to the internet. So NICs and routers makes you connect to the internet, and switches and hub they use like the second and first layer. I think hub is first layer and switch is the second layer. We're gonna discuss about the network layers in the upcoming slides, but you need to know that networks, switches, hubs, and NICs, there is a lot more than these, but these are just examples for some hardware that make networking possible. We also have some softwares. So we have protocols like TCP/IP, which is the internet, also HTTP, which is also the internet, and FTP for file transfer protocols, it's just in file system. And we have some operating systems like Microsoft Windows Server and Linux-based NOS, which is network operating system. So we're going to talk more deeply into the protocols about the network operating system. Yeah, as I said yesterday when we were talking about the system admin isn't like strictly used for just Linux. It's used maybe for Microsoft. So here we can see that we have a Microsoft Windows Server. So yeah. So we're gonna get to the topic that I really care about, and this part, to be specific, needs a little bit of calculations and it needs a little bit of understanding. So I hope you're ready to get into the IP addresses. So first thing, we're gonna talk about the IP addresses, okay? Okay, so an IP address or an internet protocol is basically a number you have on a device, on a router that makes you able to connect to a network or for devices to connect to each other. So we're gonna go on into depth that we have a public IP address and a private IP address. We're gonna talk more about them. How do they help us communicate with each other? And how do we use IP addresses? Okay. So we have two types of IP addresses. So we have an IP version 4, which is the old version that we still use till now. And we have an IPv6, IP version 6. This is used more for IoT, Internet of Things, for more of these type of stuff. To be specific, IPv4 has private and public IP addresses. IPv6 are all connected to the internet. So this is the difference between V4 and V6. So let's deep dive into IPv4 even more. So here it says it consists of 4 octets, which is 32 bits. So let's take a look at it. So if you'd understand a bit, or let me do it as text. So, okay, that's really, really small. So let me make, okay, that's too big. Okay, so a bit is either is a 0 or 1. So computers actually communicate using zeros and 1. Wait, communicate using zeros and 1, which is called a binary system. So basically, when we're using 32 bits, it means that we have 32 numbers. So one, no, that's too big. Let me erase it. Okay, so 32 bits. Let me write it down. I guess it's much better. So we have maybe 32 zeros or 32 ones or anything in between. So we're gonna take a look. So, okay. So basically here it says that it's written in 4 decimal numbers and separated by dots. So you can see here that there's like 4 parts, and every part is separated by three dots. Sorry. So it's 4 octets. So octet in Latin is 8. So we're gonna see that we're gonna separate each 8 numbers or 8 bits using a dot. So 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8 dot. And 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8. And that's it. Okay. So if you wanna like calculate it, you're gonna see that 8 multiplied by 4 is 32, which is the bits we need for IPv4. Okay, so the way we represent this in binary numbers and in binary usage when you want to like, so let me show you how we do that. So basically, in binary numbers, you can represent binary numbers using this, let me go like, can I go down? Maybe. Okay. I want to go like down here. Okay, that's fine. So when you want to represent stuff in binary numbers, you use the multiplication of 2. It's not multiplication. I think it's the power of 2. So 2, 1, 2, which is like 2 to the 0, 2 to the power 0, and 2 to the power 1, 2 to the power 2, which is, oh, I did that wrong. So let me do that. 2 to the power 2, which is 4. And then we have 2 to the power 3, which is, sorry, that's 2. What's wrong with me? Okay, sorry. 2 to the power 3, which is 8. Well, that's a great 8 right here. And 16. And then we have 32. And then we have 64. So 1, 2, 3, 4, 5, 6, 7. We still have 1. I need to do it again. I don't like this. Let me get a new page. Yeah, that's great. Okay. So let me write down. Okay, so basically we have, and I like start from, yeah, I want to start from here. Okay. Where do you go? Goes. Okay, that's fine. Okay, so we have 1, 2. Oh, that's nice. I'm gonna do it in reverse. So 64, 32, 16, 8, 4, 2, 1. I hope this is correct. I think it is. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and then 2 to the power 5, and then we have 2 to the power 6, and 2 to the power 7. I'm sorry for my bad English writing. So 1, 2, 3, 4, 5, 6, 7, 8. Yes. So these represent how you're gonna solve binary numbers. So if I put zeros in here, why am I like struggling? Let me just put it as text. So if I just inserted like zeros, we're gonna understand that this, when you add all up, it's still gonna be 0. So these are gonna still be 0. And that's it, okay? But if we added like, maybe we added, wait, so 1, 2, 3, 4, 5, 6, 7, and 8. So if we added 1, can I move it? Can I move it? Yes, I can. So if I added 1, let me move this. I just put it here. That would be great. Okay, so now if I added a 1 to the 1, and this, when we add them all up, it's gonna be 1. Let me put that down now. I'm gonna do another example. maybe a harder example, let's say. Okay, that one like was really bad, so I'm gonna put it down here and then remove it. Okay, so let's put 1, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, that's a good example. So we're gonna see here that we have ones in multiple places. So we have one in 28, 128. We have also like in 1, in 2, and in 4. So when you add these all up, so 30, 135. So this is 135. I'm sorry. What is this? 5. It's 5. Yes. So if I said I have 192, it means I have, how many is the addition of all of these? Wait, let me add them up. I think it's 255. Yeah. Yeah, it's 255. Okay. So let's see. I have all of these ones. All of these ones. So I have like 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. These are gonna be 255. The next number, uh, if like we wanna use the next number, it's gonna be 256. Sorry, 65. So I didn't know that. I didn't like really add these up. I just used the number before. So if we said that everything from here is like ones, so we can say it's 175. So just like remove one. Okay, now I hate how my whiteboard looks. So let me give another example. Let's say we have, here it is. So 2 to the power 1 to 8, 64. 64, 32, 16, 16, I said, 8, 4, 2, and 1. And I have an example of maybe, let's see, 0, 1, 1, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7. Yeah, these are 8 numbers. So if I said I have these numbers and I want to translate it from binary number to decimal numbers, can somebody do that to me? So we can see that we can add 1. I'm gonna tell you the answer. So can someone tell me what is this in decimal numbers? Yes. No, it's not 101. There's a 0. Wait, wait. Yeah, you're the correct one. I have I've added the numbers wrongly, so yeah. Yeah, so it's 101, as Sabine said. So why is it 101? Because we have added the 64, the 20, 32, and we have not added the 16 or the 8, and then we added the 4 and the 1. So if we added these, wait, is it really 101? I don't think it is. No, it's 79. Okay, so um 4 and 4 is, oh wait, 4 and 4 is, yeah, it's 101. Yeah. I'm sorry, Sabine. Yeah, 100%, it's 101. So if we added the 46, the 32, the 4, and the 1, it's gonna give us 101. I hate this number, but it's fine. Okay. So if we say that we have this number right here, we can, this IP address, let me paste it. So this means that this first number have 4 places, like 4 zeros and 1, that adds to 100 and 100 and yeah. Wait, Sabina and Omar writing. Yeah. So if we said that we have here the 192 number, so here we're gonna see that the 8 zeros and 1 adds up to 192. So let's do that actually. So let's say we have 182, 64, no, 64. Come on, my dude. 32, 16. Then we have 8, 4, 2, 1. As we said, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, and good on. So let's take the first one and put a 0, a 1 around here. So here we have 172 minus this number. Yeah, that's great. I hate it. So let's do this in calculation. So this is 12 and then 8. So 12 minus is 4, 6, and that's it here. So we have 46 and the rest are gonna be 1, 2, 3, 4. So this is the first number. Okay, this is the first number. Then we put a dot, a big dot right here. Let me remove these calculations that we don't need. So the first octet, or the first octet is gonna be double ones and the rest are gonna be 0. And if we wanna do the same thing to the 186, we can, or 68, sorry, 68, we can do that. So 168 minus 128, so 0 and 40. So that's gonna be 0 because 40 is smaller. So we're gonna take this, and then we're gonna be left by an 8, 0, 0, 0. So the next octet, which is 8 in Latin, so we have 8 bits, is gonna be 1, 0, 1, 0, 1, and 3 zeros. And 1 are obvious, they're gonna be like 1, and then the rest are gonna be like zeros. So guys, do you understand how can we like explain IP addresses and binary system? This is binary system. This is how the computer communicates. I want Zaid to ask me. Yeah, I want Zaid to ask me actually. Yes, Zaid.
Can you please repeat the last part, the 168?
Yeah, sure, of course. So we want to represent this in bits. So bits are zeros and one, binary numbers. This is how the computer communicates. عشان أفهمك إياها في العربي، الكمبيوتر بتعامل في الأرقام الباينري اللي هي الصفر والواحد. زي كيف؟ زي لما تضوي كهرباء، لما تضوي ضوء الغرفة، فأنت عندك 0 1. 0 بتفصل فيها الكهرباء، 1 تضوي فيها الكهرباء وبتشبك الكهرباء مع بعض. هلا منطقيا الكمبيوتر عبارة عن سيركت، عبارة عن دورات كهربائية، فلما بدك الكمبيوتر يتواصل مع بعضه توصل عن طريق شحنات كهربائية اللي هي الصفر والواحد. Okay? So IP addresses are the same. They work the same way. So إذا رجعنا على السلايد رح نطلع إنه ال IPv4 بتكون من 4 أوكتت. أوكتت باللاتيني يعني 8 أوكتت. Yes. So كل رقم is represented by 8 bits، بعدين بيجي فاصل بيناتهم اللي هو الرقم صفر. سوري، بيجي فاصل بيناتهم هو صفر. فإذا بدنا نعبر هذا في الرقم الباينري أو في الرقم الزوجي، خليني أشيل هدول. سو بدنا نعبر 168 في الباينري نمبر، في الأرقام الباينرية. راح نشوف إنه راح نحط 1. خليني كمان أحاول أشيل هدول. Trying these again. Okay. So لما بدنا نحاول نعبر هذا in binary numbers بنحط 1 عند ال 128. ليش؟ لأنه 168 أكبر من 128، فبنطرحها مع بعض اللي هي 168 ناقص 128. فناتج الطرح بين هدول الاثنين رح يطلع عنا 40. أوكي، ف40 أصغر من 64، فرح تحط عندها صفر لأنه literally أصغر منها. 40 أكبر من 32، فرح نحط واحد عند 32. ف32 ناقص 40 رح يطلع عنا الناتج 8. ف16 لا، و8 خلص الناتج بيطلع عنا صفر، فتكمل الباقي أصفار.
واللي ضلوا الواحد والواحد حيكون كله صفار، لأنه واحد
أي
ناقص
واحد
واحد صفر،
واحد.
اللي هم من آخر شو اسمه أوكتتس بالآي بي.
يس، هدول قصدك هدول الأربعة، الباقي
لا
صفار
لا، اللي
خلص.
فوق بالآي بي.
هدول رح يكون عبارة عن واحد والباقي أصفار. خلص، يعني واحد وسبع أصفار هيك. واحد اثنين ثلاثة أربعة خمسة ستة سبعة. آسف إنه رسمي كتير سيء.
لا
سو
مش مشكلة، واضح، بس إنه ما بنطرح الواحد من واحد، بنطرح
بنطرح
بس اللي يكون
عادي.
أصغر.
علي. ف that's it. بس يعني هي هاي الاي بيز، وهاي صعوبتها الاي بيز.
أوكي، يعني إذا الرقم في الآي بي كان أكبر من الرقم الموجود عند البيتس بنطرح.
مش شرط اكبر، عادي. يعني انا بقدر اعطيك مثلا، اعطيك اي بي ادرس، احكي لك 128 64 32 8. تمام، عادي.
هذا حيكون كله
في
صفار.
ليش كله صفار؟ كيف بدك تعب؟ بالعكس، ما راح يكون كله صفار، راح يكون في وحدات. خليني احاول اشيل هدول.
لأنه 128 ناقص 128 صح؟ ولا بنطرح
لا
64 منها؟
لا لا، ويت. هلا دقيقة. أول واحدة منه عليها 128 صح؟
مزبوط.
هل ال 128 أكبر من 128؟
لا،
وهل هي أصغر من 128؟
برضو لا.
برضه لا، هي تساوي 128 صح؟ and
مزبوط.
that's what we need، إنه ناتج الطرح يصير صفر. هذا اللي إحنا بدنا إياه. فهمت علي؟ يعني 128 ناقص 128 رح يعطينا النتيجة صفر، فلو حطينا هون واحد والباقي أصفار رح تطلع لنا الريزلت 100%. واحد اثنين ثلاثة
أوكي
أربعة خمسة
فهمت هلا.
ستة. هاي سبعة ثمانية.
أوكي
تمام.
فهمت.
يس.
آه
نيجي على 64. طب ال 64، لما ال 64 أصغر من 128، فمستحيل نحط واحد عند 128، لأنه يعني حسابيا لما بدك تجمع 100 128 هي 64، يعني منطقيا ما راح تزبط، فراح نحط محلها زيرو. we're not gonna use it. yes، زي ما حكى عمر بالكومنت. so منطقيا it's not gonna be 1. it's gonna be 0 لأنه it's 46 and 46 is less than 128. so رح نحط واحد عند ال 64. 64 ناقص 64 is 0. so the rest are zeros. اوكي.
أوكي أوكي، وصلت تمام.
yes. yes، نفس الإشي مع ال 32، نفس الإشي مع ال 8. yes، very, very great عمر. That's exactly how we solve binary numbers. By the way، هذا له دخل في الكمبيوتر اركتكتشر وفي السيركتس تاعون الكمبيوتر. وهذا بيسز، هذا بتاخده انت في توجيهي لو انك درس في الاردن، بتاخده از شيء اسمه بوابات منطقيه وباينري سيستمز. في عنا لايك فور سيستم، في عنا الهكساديسيمال اللي رح ناخده بالاي بي في 6. في عنا الباينري نمبر اللي هي 0 1. في عنا النظام العشري، وفي عنا النظام الاوكتت اللي هو النظام الثماني. So
بس
we have four systems.
العلمي ما بياخذوا مادة حاسوب. إحنا
يس
ما،
بس هلا
بس باقي
انا
الأفرع بياخذوها.
that's the problem، انه انا علمي واخذت مادة حاسب وكان فيها هاي المادة، وهي من اكثر المواد المهمة للطالب انه ياخذها. يعني ما بعرف ليش ما بيخلوا العلمي ياخذوها even though it's a very important concept to understand. كيف تحول من باينري لهكساديسيمال، لانه these things are literally used in IP addresses اذا بدك تدخل علم حاسب. عرفت علي؟ يعني هيكساديسيمال لسه أصعب من الباينري نمبرز، لأنه هيكساديسيمال أنت قاعد عم تحكي I'm not gonna like talk about hexadecimals بس راح أشرح عنها بشكل بسيط هلا. So let me remove all of these, delete. So hexadecimals are the same as binary numbers بس الفرق إنه أنت بتمشي فيها like 1 2 3 4 5 6 7 8 9 و10 بتبلش A B C D E F 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and there's 0 at the beginning here. Here there's 0. هذا نظام الهكساديسيمال. So every digit, so 0 بتكون من 4 أصفار من 4 خانات، وهاي الخانات تتحول ل binary numbers. So هاي بتكون عبارة عن zeros اللي هي 1 2 4 8. So لما نوصل على ال F وناخذ الأربع خانات من الباينري رح تكون كلها ones اللي هي مجموعة 8 و4 12 و2 12 13 14 15. رح تكون 15 اللي هي القيمة الفعلية ل F is 15. هذا نظام ال hexadecimal. Yes, me too. So these things the hexadecimal والbinary system لازم you need to understand them before you go. أنا ما بفيدني الهكساديسيمال. I really care about the binary system and the octets of the IPv4 because بالcalculations هذا اللي احنا رح نجي له إنه كيف نحسب هذا ما بدنا إياه، كيف رح نحسب هدول zeros والones وهاي الشغلات. Okay. So as we said that IPv6 we use it for IoT, we use it for multiple stuff. IPv6 is known to be كله public ما عنا private. على عكس IPv4 فيها private IPs. So we're gonna check out the difference between them. So let's start with IPv4. We have classes. صدقا I never used classes in my life and I really don't care about them. I just put them because you have to learn about them in IP addresses. We have 5 classes: class A, class B, class C, class D, and class E. Class E, you can't access it even if you want to because it's reserved for experimental uses, for we're not gonna talk about it. Class A, we're gonna talk about it. So it ranges from 000 to this number right here اللي هي تيجي تقريبا كلها وحدات ما عدا آخر bit بيكون صفر. If you wanna like, let me also remove all of these. بنيجي على ما هاي. So عنا 127 200 255 255. Oh, that's so bad. 255. So that's class A from 0 to this number. So if we want to represent this in binary, we can represent it by doing 0 and then the rest are 1. So 1, 2, 3, 4, 5, 6, 7, 8, 8, that's it. Okay. Then the rest are going to be like 0. So 1, 2, 3, 4, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 7, 8. So when we want to go to class B, it's gonna be different. We're gonna start from 128 to this number. So if you wanna represent, then if we added 1, which is in binary, it's gonna be the total opposite of this. So the 0 will become 1 and the rest will become like zeros. Yes. Because we use subnets 100%. So yes, and class C is from 128 92 to this number right here, and class D is for multicast groups. So multicast groups is where you send a message, and this message send it to a router, and the router send it to like everyone else that is in the network. It's not it's 127. This is the loopback ID. It's not 169. It's 27, yeah. It's not yes, we have we're gonna talk about it right now. The one I think you're talking about is Apipa. Apipa, yeah. The one you're talking about is Apipa, not the loopback IP. Okay, so we have public IP addresses. يعني عندنا كل هاي الأرقام عندنا from 0 to this number right here. Oh, sorry, this number right here. So we have like a lot of numbers, but some of them are private. So private is used in private networks that are not routable to the internet. So you can't access it via the internet, like literally our laptops. So let me try and show you and share my screen and open my CMD. That's gonna be scary a little bit, but it's fine. Oh, why I'm gonna do it on my CMD? Let me do it on my Ubuntu. I think it's much safer. I don't want to just put my IP address into the internet. Okay. Okay, so if we open the CMD and we write IP or fconfig, so fconfig, we're gonna see that we're having a private IP address. So even I'm gonna do it. So anyways, I don't care. Let's open the CMD. We're gonna, okay, nice. How do I know I have a virus? Oh, that's sad. That's fine. Okay. So if I write, I think IP, um, ipconfig. Okay, great. Okay, so here's the IPv. Here's my IP address. So this is for the VMware. Here's my Wi-Fi LAN adapter. Okay, so here's my IP address. As you can see, it's 192.186.1.34. So it falls into class C, as you can see here. Oops, sorry. So it's in CMD, it's ipconfig, and Ubuntu, it's fconfig or IP. So my computer and my Ubuntu server both are in the private C class, which is normal. Why? Because it's kind of easier to like, I'm gonna show you how we're gonna do that. So let's say we have multiple phones and multiple computers in your house. So we have like, especially in our modern day, I have my phone right here beside me and my laptop. So we need a lot of IP addresses, public IP addresses to access the internet. Yes, thank you, Omar. So we need a lot of public IP addresses to access the internet. We need one right here, one right here, one right here, one right here, and this is not applicable for the IP addresses we have currently in the V4. So what we do is we have a router, and this router has the public IP address. So here is public, and the rest is gonna be private. So private. And yeah, the rest is gonna be private. That's because it's easier to manage when all of the machines are private and we have one. Yes, yes. So of course it's gonna be the because it's a private IP address. So all devices in your network are gonna have a private IP address, except the router or anything that has access to the internet. And when you want to send a message through the internet, so when you want to send a message through your, like, you say, so okay, my laptop has a private IP address and it's not routable to the internet, how it can send the message? So it sends it by using the router's public IP address. It doesn't send it by using your private IP address. And yeah, that's it. So does anyone have a question about private and public IP addresses? The difference is one is routable to the internet and one is not. Okay, so we have also a few private IP addresses with the loop pack. It's this IP address right here. It's 127, oh, I'm sorry. It's 127.0.0.1. It's used for testing and diagnostics on local machines. We can do that actually. So uh, I think we can ping it maybe. I don't know. Let's try to ping the ping 127.0.0 and then 1. Yeah, so it's gonna keep sending it's gonna keep sending my device packets. So let's it's used for testing. So we can see here that my device has received everything and there is 0 packet loss. Okay. A PPA, which is automatic private addressing. This is used to when a device fails to obtain an IP address from a DHCP server. So a DHCP server, it's kind of a protocol, which is a dynamic host something protocol. I think this is the protocol that is in the router and it helps like distributes private IP addressing. So always ping. Yeah. And or trace route. We can like do trace route also. Both work. Okay. So does anyone have any kind of question on IPv4 before we go into anything? So let me stop my share screen and let me open my Azure portal. I just want to sign in, then I'm going to share my screen. So excuse me, I gave you my IP address already. I think that's enough. Now I'm going to give you also my Azure account details. Share screen. No. Yeah. Okay, that's great. You're laughing, Mohammed. That's perfect, I guess. Okay, so let's try by doing a virtual network and let's start by doing that to understand more of the. Of course, you're not gonna like calculate IP addresses and these kind of stuff, or maybe we should create a network after we like describe the CIDR and subnets. That's fine. We can do them both. So when we have a virtual network, you're gonna have a network of your own, and we can like divide the network as we like. So let's wait for that to load. Zid, what's wrong? Are you overwhelmed? Are you overwhelmed? حس حالك هيك كثير عم تاخذ معلومات. Welcome to networking, I guess. So apparently my Azure is needs a little bit of. Okay, so let's continue. Okay, so we're gonna like see what Zaid has to say, and then we're gonna go to IPv6. Okay, so IPv6 is more for IoT stuff. As I said, it's more for Internet of Things, smart houses, and these kind of stuff. We have said it consists of 128 bits, which is 8 groups or 4 hexadecimal digits. So we have 4 groups of hexadecimal digits. So every digit is like literally 4 numbers. So you have to do the math, I guess. So I think it's 4. I think if you wanna like calculate it, it's 4 from 4 and 8. I think this is how we do it. So it's 16. It's 16 times 8, and let's do that on our calculator, which is like basic lab. 16 times 8 is 129. I don't know if you can see that. So here we can see that it's 128 bits, which is equal 128. So why 4? Because we have 4 digits, and every digit has another 4 binary digits, and it's out of 8 groups. So we don't need these kind of stuff. So the features of IPv6, these are more for web development and stuff, especially the simplified headers, larger address space. Of course, there's billions and billions of IPv6, so billions and billions of IP addresses. Auto configuration and enhanced security. So these are the features of IPv6. We're not going to be using them today, so I'm not going to really dig deep into IPv6. Okay. So we're gonna also talk about, we're gonna talk about one of the most now important topics of networking. We're gonna talk about subnets and CIDR blocks, and we're gonna describe and give some examples. And I'm gonna show you how to calculate a CIDR block, even though you don't have to do that because it's, why is it working? So I want to create a, yeah, okay, so that's good. Okay, so no problem. Okay, so we're gonna talk about the subnet, which is dividing a network into smaller subsets, let's say. So it's literally called a subnet because it's a subnetwork, so apart from a network. So to improve manageability and security. So if we went back to class A, we can see if you wanna, or not class A, so let's go to class C. So we're gonna see if you wanna use class C like we're having right here on our Ubuntu terminal. We see that we're from class C. We have like 2 million and a lot of networks, so 2 million and a few networks. So we don't need 2 million and a few networks to have in our home. So we subset this network into CIDR groups or CIDR blocks. So classless inter-domain routing is a method to allocate and route that replaces traditional class-based system. So if we said it's slash, like anything slash 24, this is a subnet mask, or this means that it is classless. So we have two things. The one we have seen like before, we have class. Oh, let me fix that. So we have classes, which is contains four class. So class A, B, C, D, E, and we have classless, which is CIDR blocks, and it contains anything that has the slash like number. It's considered classless. Okay. So the calculations of CIDR blocks are kind of easy. It's why I have talked about the zeros, like when we talked about the IP address like 127 maybe, and then 128, 255, 255. So and then we're gonna say like 24. Okay, so this is a classless example of an IP network or a network. Even though this is very wrong, I don't think this is correct, or we can do that, but let's just say it's an example. So when we want to use that, we're going to see that there's 24 here, the number 24. So remember we said that these numbers are 32 bits. So this is really important to keep in mind. So these numbers are 32 bits, 32 zeros and ones. Oh, that was like really bad. So let me, okay, can I do that? Okay, I was searching for you. Let me delete these. Okay, let me delete you also. I'll take a screenshot. Okay, so the calculation for CIDR blocks are like easy. So anything from um, we can see here. I don't want IPv6. So if we said that we have /24 is we say that anything like let me calculate it. I can do that. Okay, so if we said that /24, which is basically 32 minus x equals 24, so x is 8. So if we want to like translate this into binary numbers, we can do that by using 1, 2, 3, 4, 5, 6, 7, 8, 0. 1, 2, 3, 4, 5, 6, 7, 8, and then dots. And then 1, 2, 3, 4, 5, 5, 6, 7, 8, and then another dot. Why it keeps getting bigger? And 1, 2, 3, 4, 5, 6, 6, 7, and 8. So this is the IP address. Oh, don't do that. Okay. So now when we look at this, let's go back. So now when we look at this, we can see that 24 bits are ones and the rest are zeros. So let's do that. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and the rest are gonna be 0. One, two, three, four, okay, I think please. So why did we do that? Why is like what is happening around here? What's going on? I don't understand. So I'm gonna tell you. So minus 24 is basically the if you can see here, minus 24 is, if I'm not mistaken, is the network host. So this is the network host. And the rest, which is 8 or X, is the not network host, is the host. So this is the network and this is the host that we're gonna work with. No, no. And we remove this. Yeah. So this is the network and this is the host. So we have 24 networks, as you can see here. So 24 ones. So network is 1 and host is 0. So we just counted, like, there's 32 bits. These are 32 bits of the IP addresses. I'm not putting them inside of each other. Not inside, actually beside each other, because it's gonna be like really long and I don't want to do that. Well, let me do that. Why not? I'm gonna use the bigger number. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 and then continue. I think it's gonna be like really long. So there's a dot. 1, 2, 3, 4, 5, 6, 7, 8, and then like a lot of zeros and stuff. So yeah, I told you it's gonna be like really long. So as we said, like /24 classless network bits, which is 24 ones, and then the rest is 0. So if I said I wanted if I wanted /25, we're gonna remove this 0 and put 1 in here. So this is gonna be 25 ones and 7, and then 7 host bits, which are gonna be the zeros. Okay, so this is the CIDR and subnetting. So let's give an example. maybe I think it's better for us to understand by an example. So we have a company with different departments and we have a network. So we want to sub this network into multiple departments. So their network is 22. This is their network. Okay. So based on our drawing, if we want to say 22, we're gonna remove this and we're gonna remove 2 ones. And we're gonna put here 0 and 2 zeros here. So this is gonna be 255, 255, and this one here is gonna be 252. Okay, yeah, exactly. 255, and this is the subnet mask. And this is gonna be 0 because it's all zeros, so 0 dot dot. Okay. So if we went to the subnet and we calculate it. So in cloud, you don't have to calculate it. It's gonna give you this already. We're gonna see that the 24 has a range from this to this number, and we're gonna see that. So let's do that. So let's create a virtual network, and we're gonna call it company ID. I don't like the calculation of IP addresses and these kind of stuff because here it is, IP addresses. Okay, great. So we have an address space of, let's go back to it. We can do that, or we can do tens, but I think tens are a bit easier to understand, and let's like make it a little bit smaller because yeah, this is like good. So this is our network. Yes. Does anyone have any kind of question? Okay. Okay, so here we have a network, which is 10. It's a private network. So if we went back to the private IP address, we're going to see that it's in the private class A. So let's go back to our question. And then we have it as /21. So this is the entire network, or let's put it /22, like the question has. So it's 100, 1024 addresses. And now we're gonna subnet it based on four departments. So let's do that. So let's put a subnet. On the first department, it's the marketing department. So let's do that. So yeah, default, and let's say marketing department. And then we're gonna say, okay, let the range start from like this. And yeah, here it is. So it has already put the 24 for us. So it have started from zeros and then it have ended in 255. The thing we need to know that there are a few IP addresses that are reserved inside of a CIDR block. So in cloud, it's typically 5. We can add IPv6 here, but we are not gonna do that. Okay, sorry. Let's begin with the letter. I think we should put a dash. Okay. Okay, so here we can see that the range is what we use, and then we have like did multiple. So from 1, I don't want it from 1. I want it to start from 0. So 0, 0. Yeah, that's good. So if our address start from 0, let it start from 0, and let's add the marketing department. Now let's add the sales department and do that. So sales, and then department. And it's gonna start from 1, of course, because it ended to 255. And it's gonna end also at 255, which is like reasonable. So let's add that too. Let's do what department? IT and finance. Okay, so IT department. So IT department. And exactly, yes, from two. So you see here, we don't have to like calculate any kind of thing, and we have the last subnet, which is the finance department. So finance, sorry, new space, yes. And we have here the rest of the network, and now it's gonna close. Like if I try to do another subnet, it's not gonna allow me to do so. So here you see the address cannot be given because it's gonna overlap with any address we have right here. So it's not gonna give me the ability to do any more addresses because the address, it starts with the zeros and ends with this number right here, and we have started with this number and ended with these numbers as well. Okay, so now if we want to review and create, we can do that. And now we can create our own virtual network and subnets using Azure, which is like takes a few minutes and you don't even have to calculate anything. Yes. So this is why I don't want anyone to like go into the calculations, because you can do this like basically on you see here development and process. It's gonna like take 2 minutes. Okay, go to resource, and here we can see our virtual network. It just needs settings. We can pair it with another network. And here are the subnets. So if we open subnets, we're gonna see the subnets we have right here. So available IPs, we said it's like the last number it gave us is 255. So why is it 251? Because there is reserved IPs that are used for the cloud. I think there is 5 reserved IP addresses that are reserved for the cloud. There are 3 that are typically reserved, which is the broadcast, the network, and another one I don't remember, or 2. Yeah, 2. Sorry, 2 are like typically reserved into anything, like any kind of network, off-premise, on-premise, on-cloud, off-cloud. There's 2, which is the network one and the broadcast one, the first and the last one. Okay. So protocols and ports, we're gonna go through this like fast, not fast, but it's one of the most important concepts. This is what we're gonna use like a lot. So we have these layers. These are really important, but I really don't have the time to like discuss all of it. We have 7 network layers: physical, data link, network layer, transport layer, session, presentation, and application. So typically routers use the network layer, the switches we said use the second layer, and the hubs use the first layer. So if you're linking devices using the second link, this is LAN. If you're linking it using the third one, this is WAN. And then going up is how how the communication goes. So when you want to send a message, it goes from up to down, and when you want to receive a message, you go from up to down, and when you want okay wait when you want to send a message, it goes from layer 1 to layer 7, so from down to up. And when you want to receive a message, you go from 7 to 1, which is from up to down. Okay. We're gonna go like over the protocols. They're easy. There are a few slides, and then we're gonna take a 10-minute break because I know you need it as much as I do. So we have a lot of protocols. We have the HTTP, which is like basically anything. So if I open this doc, you see here there's HTTPS. If I opened Azure, we're gonna have HTTPS. So this is basically HTTP, and HTTPS is secure version of HTTP. This is transferring web pages over the internet, so they're on different ports. FTP is file transfer protocol. It's used for file transferation between client and a server. And this is on the application layer, as you see, which is the 7th layer. So also we have SMTP, which is simple mail transfer protocol. It's used for sending mails, and retrieving mails are POP3 and also I don't know. There is another one. I think it's ICMP. And we have the DNS, which is the domain name system. It's port 53. And if you look at AWS DNS servers, so AWS DNS server, you're gonna see that's called Route 53. So Route 53 is for the port 53 of the DNS. This is a DNS service from AWS. You also have a DNS service here. So if we write here DNS, you're gonna see that we have private DNS zones, DNS, and I think here, DNS servers. Yes, we can like DNS is it's used for translating IP into domain. So Google's domain, I think if we write 8888, yeah, yeah, it should open Google. It's Google, Google IP address. It's 888. That's reserved. Yes, there is also a thing about layers that I think all people remember. There's a thing I forgot what's called. I think all people think remembers eating pizza, and this is like pizza or something. I forgot how it's okay. But you can see here if I again wrote 888, it's gonna open the Google public DNS, so that's good. So let's enter I wanna enter a DNS. Let's try no, not 10. Let's try 7, 4, 3, 1, or 2. So resolve. What did it give us? Okay, let me do that. Let me do 7, 4, 3, 2. What will it give me? I'm afraid it will open the dark web. I don't think it will. Okay, maybe it can't resolve into a server. Or it's fetching it from like a big server or something. Okay, true, false. Name. Yeah, it's not retrieving anything from the DNS. Yeah, basically, yeah. It can't be reached. It's fine. Okay, so we have in the application layer, in the transport layer, we have UDP and TCP. These don't have a specific port. The difference between UDP and TCP, this is like Facebook Live. It kind of like sends the files without checking if it's delivered or not. So UDP is like literally Instagram, TikTok, or Facebook Live. They just like send packets without caring if it's delivered or not. So this is called a connectionless network. And TCP checks, it's more reliable than UDP. It checks if the message is delivered, and it's called a connection-oriented model. So we're gonna use this a lot. So TCP IP, UDP. We're gonna talk about TCP packets, UDP packets. If you're a cyber student, you're gonna see that we have UDP floods or TCP packets using DDoS attacks and DOS attacks and all these kinds of stuff. So session layer, we have the RDP. So here, if we open the RDP, more remote desktop connections, literally. So it's a desktop connection. So we can open a virtual machine right over here. Maybe connect. I don't think it's going to connect. We don't have any kind of RDP to connect to. This uses the protocol 135. Okay. So we have on the database, okay, sorry, this is security layer. I don't know why it's database, so security layer. So in the database layer, we have MySQL and PostgreSQL. So they're both used for database access. So Postgres is 3306 and Postgres is 5432. On security layer, we have a such which is secure shell. So when you close this, it's still trying to connect. So no, not help. Don't connect, please. Now, are we using UDP in our broadcasting? Exactly. We're using now UDP in our broadcasting right now. Okay. And telnet is literally when you're trying to access a server without you physically being there. So this gives you the ability to access a server without you being there. It's used on port 23. Okay, so let's take a 10-minute break and then we're gonna discuss about networking in Linux quickly. Allow us SSH. I don't have anything to connect to, so let me stop the recording, and this is gonna be part 1.